Welcome back to Meshmen Studio. So in today's episode we're going to talk about ACEScg and how we can configure ACEScg to work from a VFX Nomads perspective, because recent event has forced major parts of the VFX industry into self-isolation, and me myself, like here, I really need a good color managed workflow to be able to do my texturing work. So I'm going to take a look at how we can configure my OCIO profile to work for both Mari and, in my case, Renderman for Maya. Some of the caveats, because I need to configure them a bit differently for the different needs, and so we can get them both to work as expected. And also I'm gonna link some really good documents that you can read up on internet about ACEScg. So yeah, let's dive into it now and get that color managed workflow going. Okay, so let's take a look at this now more from a texturing perspective. So yeah, if you search on ACEScg versus sRGB, you will probably find one of these on the internet. It's essentially a diagram over the gamut of the different color spaces, sRGB and ACEScg. So for example, you have something here called the primary colors. So if you look here at this one, the red line here is going to be the color space, or the entire color gamut of sRGB, what that color space can produce. If you look at the topmost corner, this is green, red and blue. So that's the dimension of that color space. ACEScg it's a lot wider here, especially if you look at the green, it goes up there. The blue is kind of closer. The red is also a lot wider in ACEScg. So it's a much wider color gamut. Most images on the internet, or anything that's really shown on a monitor, is probably coming from an sRGB color space. It has an sRGB gamma encoded into it. I guess traditionally a bit like, what is gamma really? And to be honest, I'm not a color science guy, but just explaining this a bit like from a layman's perspective. If I would look at a television screen, it has a resistance, or traditionally it has a resistance, and you have to compensate. So if you would take a picture using a camera sensor, let's imagine that this is the sensor and the input is for the sensor is linear captured, but the monitor that's over here can't display. If I would show this image on the monitor, it would look too dark. So what we're using the linear representation from the sensor. So what the monitors do, they apply like a gamma curve onto the images, or the images has a gamma curve encoded to accommodate the loss in intensity, especially in the mid-tones. All the calculations in rendering has to be linear, because otherwise it will be wrong. So what we do then is to take our sRGB image and we reverse the gamma. So we take the reverse of that curve, and that produce a linear representation. So that's essentially a bit what happens in a color managed workflow from a very low level or a high level, or whatever you say, perspective. So going back here now to the image again. So we see here, if I in an sRGB space would say, pick a color here, pure green, but in an ACES color space, that pure green, if you would translate it, it would not be reaching the limit of the spectrum. You see the green here goes way above outside. This is something that ACEScg is a really good color space for rendering, because it's wide, but it's not as wide as the ACES. There's another one, ACES, that's even wider, and that one proved to be like a bit too wide essentially for rendering, because if you would take another color space and translate it, can produce negative values as it is at the moment. So that's why ACEScg was introduced, from what I understand. So we now want to look at how we can convert sRGB images into ACEScg. So that's mainly what in texturing what we do. We have a lot of source images coming with sRGB as the encoder gamma. We want to take it into ACEScg and convert it in a way that we maintain the look and the feel from the sRGB, but we encode it in ACEScg so it's future-proof and works good for rendering. So that's something we need to do, and that was why, for example, Mari introduced the ACES workflow. In Maya 2020 here, we want to use the it here, but to use it with ACES, we need a OCIO profile, essentially. So let's take a look at the problem. We can see how we can fix it. So if I open it here, you can see here, if I go to my view, my image color space here, to be able to look at ACES with the correct look, we need the input transform here to have the ACES, and it's not configured by default. Looking here at my color config here, so I go to this guy here in the corner, go to color management to see here, I've actually set up ACEScg and sRGB, and everything is fine there from that perspective. But if I want to use it, that will not work out of the bat. So we need to download an ACES LUT essentially, or an ACES OCIO config file. So there's a few ways to do that. So let's take a look at where we can do that now. Okay, so here's one page with documentation about OpenColor and OCIO. So opencolor.io.org. Actually, on GitHub, there's also here, if you search on GitHub on OpenColor.io, you can see 103 is the latest you can download, but you can actually, there's a later one that's the ACES 1.1. I'm not entirely sure the difference between them. Nuke at this stage ships with 1.1 if you want to hijack that OCIO config as well. So that's what I did. So I downloaded the new non-commercial and took the 1.1 config from that directory. So let's take a look at where that one lives in Nuke if you have that one, or you can just download this ACES 1.0.3 there. Okay, so here in Nuke here, let's go to plugins, OCIO configs and config. There you actually have 1.03 and 1.1 there. So what I did, I took this one here, I copied it, I went to my C drive. So I made a folder here with OCIO and I pasted it there. So it's, if I change my, like my install or something, it's in another area. So yeah, Nuke ACES, this is the vanilla one. So I actually configured some here later on for Mari use, but let's take a look at first how to install the default here. So this is the one I copied from Nuke here. So this is the directory we want to access first, and then we want to go here to my environment variables here in Windows. So environment variables, and go to environment there. So let's delete this one and make it from scratch. What you want to do is to user variables. This is for me. You want to create a new one, and you want to name it OCIO, like that. All capitals, and variable value, you want to browse for the file. You want to go to this location where you ACES here and take this one, the config, and there you go, and set OK. Yeah, okay. And now let's relaunch Maya and see that we actually have the config now. So let's do that. So here in Maya, we can see here now, if I go to color management, my OCIO config path is actually set to the same path that I set with the variable. So that's good. And we can see here that my rendering space is ACEScg and my view transform is sRGB. So that's cool. And we can also see here my view transform up here in the viewport is now sRGB ACES. So that's good. So let's now here actually just hit this guy here and open it and see what if something changed, and it should have. So image color space, you can see here we have all of these now possible image color spaces. ACEScg here is what we will use up there when we render. So let's actually take something here. Let's create a polygon plane. There you go. Let's do this. Let's create a constant. Let's take this guy, graph material, pixel constant, make a pxrTexture. So we want to have this guy, the color checker. This is one is ACEScg color space. Let's plug it into my mid color there. Now actually let's render this first in the viewport and see what happens, and just turn this on to Renderman. And there we have my color checker here in ACES using sRGB. So let's turn this off and go to raw. I'm gonna see this is the raw values, sRGB. Let's turn this off and actually go now here to my IPR render. So see if we get an ACES, and there we go, image. So my image color space, ACEScg, and my out transform display view is gonna be sRGB, and you see it's the same there. So that's good. So now let's actually dive into see how we can do some configurations for Mari, because it's a bit of a conundrum here to get them both to work actually, because Mari has some color space or Mari rules that need to be set up if we're gonna get this to play nicely. Okay, so yeah, so going back here to the Mari side, first off, I want to demonstrate something. I want to go and edit this environment variable and just put some bogus like ACO B, so it's not recognized for color management. And now let's start Mari. So let's go to Mari and see here. Okay, so if I create now here a new project here, my color settings. By default here we have the Nuke default and the ACES, and you can see here if I set it to ACES, the 16 and 30-bit float is going to be Mari float ACEScg, and this is the working color space, the internal color space that the images that, for example, if I would import an sRGB image into Mari, it would be converted into ACEScg, for example. That is something I want to do as well when I use my OCIO profile. Out of the bat, that might be a problem. So we're gonna see what happens if I now set this same OCIO config that I used for Maya and it. So let's do that. Let's see here, I have my OCIO B there, I edited, so uncomment it, and let's just say OCIO and save, hit OK. And let's go and open the Mari again to see what color config we will get now when I start my project. Let's make a new project and look at the color settings. So now we can see here, yeah, it's actually picking up my environment variable, so that's good. But if you look here at the scene linear, that's ACEScg, that's good. But these color space rules here that previously was sRGB color space is also ACES, and that's something I don't want to use in my workflow, at least, because I want sRGB images to be converted into ACEScg. In this scenario, it wouldn't touch them really. It would be a bit strange if you would have an 8-bit sRGB image. It wouldn't be converted in a predictable way. So let's see how we can fix that. Okay, so here in the program files directory, we can locate Mari 46v3 here and go to bundle, media, and color. And there we have open color IO. And I want to locate the ACES folder here, so let's go inside, and there we have the config OCIO. So let's take a look here how that one looks inside. So let's go to edit and take a look here. So this is what has been added, the Mari int 8 and 16-bit utility sRGB texture. So this is input transforms. It tells if you take an sRGB image, it's gonna be an input transform that's gonna then convert it from sRGB into a ACEScg linear color space. So it's gonna reverse the gamma that we talked about earlier. And so yeah, this is the extra stuff that's been added on top of the regular OCIO profile that you can download from other packages. So this is a more specific thing. So essentially, if you have an OCIO profile, you need to add this if you want to have this workflow for Mari purpose. So let's just take this, close it, and actually go back and just take this ACES file here, or the directory. I'm gonna put it just here under my Windows, and let's make a new folder called OCIO Mari. So I know what it is, paste it there, and go to my environments and set it up. I want to point OCIO here to this new location instead. So Windows, OCIO Mari, ACES, this one instead. Start Mari and see that it picks up this custom one, or the same but now through the environment variable. Here if we now create a new one here, let's see what happens. Go to my color settings. So now we see here, it picks up my config here, and it said C drive OCIO Mari ACES config. So, and you can see here now it picks up those settings that I looked at there earlier. So if you download the OCIO 1.1 profile, for example, you have to add those rows there to the header there where the roles are. So that's one of the things. So yeah, so let's now actually dive in here and take a look at some of the settings here. So some of the things here that's interesting is, for example, if I go to Image Manager and import something, let's take a ACES, this one for example, the ACEScg EXR here. You're gonna see here that in EXR, it's gonna default here to the color space ACEScg, and that's because it's a 16-bit color. So it looks at a few things. It looks at names and also by bit depth. And going back here to the settings here in Mari, this 1632-bit float data, it's set to Mari float ACES. So in Mari, this is gonna be the internal color space. That's everything is gonna be converted to when you import anything. So in my case here, let's say that I take this one here, ACEScg EXR. Essentially, it's already in an ACEScg color space because it's pre-converted. This one is a Macbeth chart. Let's stamp this down. That's all fine and dandy. Let's say that you want to import sRGB image. Let's say that you have something that you downloaded from the internet or something. Let's say that let's take something on my desktop. This is an PNG file, it's an 8-bit file. And you can see here now, automatic utility sRGB texture. So this is the input transform. It's gonna essentially look at the bit depth and file format and figure out, okay, this one was created probably in Photoshop or something. It has it assumes that it's an 8-bit, has sRGB gamma and like built into it to compensate. So what it does, it essentially takes the inverse of sRGB into ACES linear color space when you import this one. Let's drag this on here and just stamp this on. We get this. So this one is now essentially an sRGB image imported into ACES, and we can turn off color management. So this is the linear representation of ACES. Is kind of dark and saturated, and when you turn the LUT on, sRGB, or we can take the Rec 709 LUT, it's a bit less contrasted, the Rec 709, you can see this. But there is one thing when you import something from sRGB. If I would look at this image on my desktop, so let's do that, go to my desktop and open the same image, it will not match 100%, and that's something that's described more in documentation around it. Essentially, if you go to Autodesk, and I'm gonna do some links in the description to some interesting reader. So let's get physical, let's take the same. You can see here that essentially this one is a bit, if I take this to sRGB as well, they will not match when I import it into Mari, and that's actually, I think, by choice. From what I understand, this is something that's deliberate, because you can actually expose up the images a bit more without losing contrast. If we can do a test here quite quickly. So this import transform that is applied here when I import it, you see utility sRGB texture. So if I would set this instead of this utility sRGB texture, you can go in here and override different color spaces. So if let's say that you have something in that you know is shot in something else, you can have a linear sRGB if it's already linearized. You can also have different cameras. If it's a known color space, you can override it so it's actually imported correctly if the file format is not picked up. But we can make a test here and import it as output sRGB, and it will actually match more closely, but this is, from what I understand, not the correct workflow actually. So, but we can make a test here to see what happens. I drag this on here, and then we take my same image from my image viewer here, and they actually is pretty close, almost spot on there. But as I said, it's not actually the correct workflow. This one is from ACEScg perspective a better starting point, even if it's a bit darker there. I think it has to do with, if I would expose this up now by a lot there, you can see that it behaves quite predictable, except the decal there is pure black, shouldn't be. Take this one, temp it down. You see that it loses essentially, if I take this other that's imported and output, it loses a lot of the values there quite quickly if I use this as an output. So this one retains energy much better. The first one, if I paint it on, it's more physical correct apparently. So I'm gonna make a link in the description about where you can read up on this as well. So yeah, that's the basics of how you can import images from an sRGB color space into your ACES project. And also you have, if I go here into this select color, you can select color here in either 8-bit, and that's the default, 8-bit utility sRGB. So you essentially selecting color in an sRGB space, but it's converted into ACES. And you have values here. So if I would pick this green color here, let's say like 1 in green, you can see here source and target. So let's say that you have 1 here, like in sRGB color space, 1 is the pure color, but in ACES this comes to the how the primary color wheel is mapped. So that we talked about earlier, you can see that in sRGB green, pure green, is not pure just 1 color in ACES, because the primaries is how they are, how expanded they are compared to the sRGB color space. So you can see here in ACES, this value that's pure green is not just 1 value, it's 0.34, 0.916 and 0.110 there. So yeah, that in ACES, linear ACES, this will produce the same value as that. So yeah, that's also if you sample something. Let's say that you sample this color in sRGB, you will get this value in ACES. So you can, if you would do it, you can also go here and say, okay, I want to sample something in ACEScg, and then you will see the ACES color. But generally, for most of the time, I have it set to the default. If I'm working on something that's in, screen space, or something that's, colors coming from internet or anything. So yeah, that's a bit about the ACES and some of the tools around how we can pick colors and convert colors. And it's important to know what color space, and if something is in 16-bit, make sure that it is pre-converted to ACES. Otherwise, if it's a linear, if it would be a linear sRGB image. So let's say that you have something that's linearized from sRGB into the linear representation of sRGB, and you import it as a 16-bit color, that will not actually be correct. So you need to be sure that if you import something like an EXR, that it's already converted to ACEScg color space, and you can do that in Nuke or other programs. You have to do an OCIO transform, and that's something that's generally handled by a pipeline. Or you import sRGB images and convert it into ACES on the fly here. So yeah, that's a bit about the ACES in Mari briefly. I'm gonna now switch gear to look at some of the things from a Renderman perspective. Okay, so here in Maya 2020, I have loaded Renderman, and I want to take a look here at the pxrTexture read node. So let's say that you have an sRGB image and you want to use ACES, and unfortunately there is no easy solution for this at this stage using any of the Renderman tools other than importing already defined ACEScg images. Because if you, for example, if you want to take something that's in sRGB, you need to linearize it into an ACEScg, so you have to reverse transform from sRGB into ACES. And to be able to do that, you need some kind of color space input rules, similar to what we had in Mari. Problem here on the texture read node here, you have this linearize button, but if you hit this one, it's actually gonna reverse from sRGB into a linearized sRGB, but we are rendering in ACEScg, so you will not get the full benefit. It will be a bit of a issue there. So that's not really an easy way to get around at the moment. And you would think that, okay, let's take a Maya file node just to take a look, because that one actually has stuff here, but this doesn't work in Renderman. I can show you the docs about this. So this is essentially what needs to happen in the pxrTexture read node. We need to have this color space, so we can see here, okay, the color is either in ACES, or you would go to an input sRGB texture, for example, the same that we have in Mari there. This one, I tested it, and it's not supported for the Renderman workflow, and this one doesn't work. It just linearizes into sRGB. So this one only works if you are purely using a linear sRGB workflow. So the only option at the moment that I found is actually to convert everything as ACEScg from Mari, and that one will be the only way to get it to work properly at this stage until Pixar implements color space rules. Either they support the one that they have here, or they extend on this one. So that's a caveat. At the moment, there is no way to take a JPEG image and get it into the correct reversed color space sRGB into ACES. So let's take a look at the docs here and take a look as well. If we look here at the documentation, the Maya file node provides convenient ways. However, Renderman only supports a subset of the control base of the preferred workflow. So yeah, nothing is mentioned. I tested it didn't do anything, these settings found here for the color space. And also here, looking at the pxrTexture, so let's see here, pxrTexture, there is nothing that makes you linearize it. So apply the reverse sRGB transform. So yeah, that will only work if you are working in a linear sRGB workflow. So yeah, that's a bit unfortunate, but let's import an properly ACES file here anyway. Let's take this one, ACES EXR, onto my emit color there, and go to TX Manager, Color Checker Classic, onto a plane, and we have different LUTs here. So I like the Rec 709. It's a bit yeah, nicer. Let's shoot this off here and go to IPR, and it's set up. So it's using the same OCIO profile as I use for Mari, and it picks up my config when it comes to colors here as well. View transform Rec 709 there as well. So that's fine, and you can see also here under image color space, it is all of these to choose from, but ACES is already set up. So that's fine, but it's unfortunate that you can't choose input color space if you want to apply something. Let's say that you want to apply like a tallable texture. So either what you have to do, let's say that you have this concrete albedo texture here. So this one is sRGB color space. So let's take a look and see what happens if I apply that one without linearizing it. And now you can see here, it doesn't at all look like the preview we saw here, unless if I go here and take the preview of that file. In the preview, this is how it should look like in sRGB, but clearly when we render it, it's not linearized. So that's something you need to do for colors. So if I would now here using this pxrTexture read node using an sRGB image and hit the linearize button, that technically will not be correct because it doesn't linearize to the correct color space ACEScg. So let's see here what happens. Looking at this, you see the difference in color here. One is greener than the other, and that is one part of that problem is the difference between the primaries and how it remaps color. So there's always going to be a shift between that because technically we're not correct there. So what you have to do is either to pre-convert it to ACEScg using Nuke or some other program that supports OCIO transforms, export it out, convert it from utility texture into ACEScg. You have to have a custom texture read node that can leverage the color space conversions in the texture read node. Okay, so let's dissect this problem a bit here and see what's really going on. So I have this JPEG image here in Nuke, so we can more easily demonstrate how this works here between the different color spaces and what issues it could be when you start to mix the wrong color spaces. So first off here, let's take a look here on the read node itself here. We have these color space rules. It says the color space is default sRGB, and we have sRGB image here on the LUT. So let's turn this off first so we can see. So now this is essentially the linearized value of default sRGB. But to more clearly understand the problem, I'm actually gonna turn off color management on the node. So we set this to raw. And now you see now it's read in the values. It disregards the color space because this is dimmed out. And you can see here my LUT is set to none. So now we're essentially displaying whatever the image looked like on disk. So this is we can see the sRGB LUT here is applied and it comes with the image. So if I would set now my LUT here in Nuke to sRGB, it will become very much brighter here, and that's because we essentially now have two LUTs applied, one from the image and one here actually in Nuke itself, essentially. So if I turn this off here to none and have this to raw, I'm gonna now actually go here and do the linearization here using the color space node. And this one here, for example, if I now clear this and look at it by itself, this one I say, okay, the in color space, that this image comes from a sRGB texture, so that's sRGB color space. And I wanna transform it into the Mari working ACES. So this is essentially the workflow. If I will work in Mari's, it looks at the image. If it's an sRGB image, it's gonna take it into an ACEScg color space. So let's see what happens. And if I view this node, now you see here, it has linearized it. It has taken away the sRGB gamma. So now it should be in a ACEScg color space. And then we paint with it, and then we take the data we have and display a LUT. So this node here is essentially displaying a LUT, so it's OCIO display. So we have to then first tell it what working space it is. So we say input color space Mari working ACES. So we know that we have linearized this into ACEScg, and now this node expects ACEScg, so we tell us here input color space will be Mari working ACEScg. We display device is ACES, so we want to apply this sRGB LUT, so let's do that. And now it looks like that. So now let's take a look here what happens in the Maya example when we apply something here. For example, you know that we get this color shift that I explained earlier. So let's take a look at this node. So we know here at in color space is still Mari utility sRGB, but the out color space, if I would hit linearize button onto an image in Maya, it would take it to linear sRGB. So let's take a look. So this node, if I compare these two here, for example, when we see that this one is linearized using ACES, this one is linearized using linear sRGB. So let's take a look at the difference. You can see that there's a shift there in color. So this one is a bit redder than the other. So now let's attach here a display device. So let's set this to, first off, be utility linear sRGB. So it's expecting the same color space here that this node has, linear sRGB, and we display it using ACES and it's sRGB. So let's take a look between now in the view transform, and they should be identical. So that's cool that we have now set this in color space. But what happens when you do it in Maya? You are still rendering using an ACEScg color space, but you apply a lot for something else. So essentially, if you want to preview that scenario, let's take this one, copy this chain here and paste it in, and take this one and rotate it. So we essentially want to take it into, what happens then is we take this input color space and we assume that it's ACEScg, but it's not. And then we display it using sRGB. And then we will get this shift. So that's the shift with the LUT apply. So that's essentially what we see if I would display something uses the linearize of a JPEG image in Maya. If you would linearize something in Maya for Renderman without setting this color space rule somehow in the read node, you will get the shift you see there. And that's something that's really hard to get past because the tools in Maya at the moment doesn't take this into account. So that's a shift you might expect. So that's why you either have to go this route here and actually take it into something like Nuke here. You apply this color space transform, take it from utility sRGB texture into Mari working ACEScg. That's the correct way. And then you use this image to apply inside Maya, and you don't have to linearize it then because you already done that. Then you can apply the LUT and it will work. And it will look more correct, similar to what you expect the image to look like when you apply the LUT. So that's the problem, and that's also the solution. But unfortunately, the solution is at the moment you have to either pre-convert if you want to use ACEScg with the texture read nodes in Renderman for Maya, or any Renderman node, because the pxrTexture read node doesn't linearize to the color space, it linearized to linearized sRGB, and that's the problem. So that's something that the Pixar needs to fix. Needs to have more modernized color space aware nodes, similar to, I guess, what Arnold have introduced, that use color space rules on the texture input, similar to having this ton of drop down here.